Greetings of the day. My name is Yawar Ayub. I have done my MTech from NIT Srinagar. Currently, I am working as an assistant professor in the Department of CSE Data Science at MITS College. My today's topic is random forest algorithm. This is the flow of presentation. In this presentation, we'll discuss the introduction of random forest algorithm, what is the intuition behind random forest algorithm, what are the assumptions that we have to consider before applying random forest algorithm. Then we'll discuss working of the random forest algorithm. Then we'll see implementation of random forest algorithm using scikit-learn library. Then what are the advantages of random forest algorithm. Finally, we'll discuss key challenges of random forest algorithm. What is random forest algorithm? It is the commonly used supervised machine learning algorithm trademarked by Leo Bremen and Adley Cutler. It creates an ensemble of multiple decision trees, usually trained with bagging method, to reach a singular, more accurate prediction or result. For random forest algorithm, it uses decision trees. Now, what is a decision tree? Decision tree is a tree-like structure which is used to make prediction based on the set of rules. So random forest algorithm, it handles both classification and regression problems. That's why it is most widely used algorithm in machine learning. So let us discuss intuition of random forest algorithm. A single decision tree has high variance and it may overfit. To handle this problem, we'll use multiple decision trees, and we call this problem random forest algorithm. In a random forest algorithm, it builds multiple decision trees and then it aggregates their prediction. Therefore, it reduces variance and increases generalization. Each tree is trained on a randomly sampled subset of data, and we call this process bootstrap sampling. Also, a subset of features is selected randomly. That means in random forest algorithm, when we build trees, decision trees, we will not use all the features. We will randomly select subset of features to make trees more diverse and decorrelated. So this is the random forest algorithm. This picture I have taken from Geeks for Geeks. So in this, as it is shown there, so this is the picture of random forest algorithm. Here we take our training data and we use multiple decision trees. We train our data in these decision trees and each decision tree make their prediction. Finally, we decide, okay, if for example it is a classification problem, then we will go for majority vote. For example, if there are 10 decision trees, we'll see, okay, what is the majority? If the majority of the decision trees are predicting class A, our final prediction will be class A. Or if it is a regression task, then what we will do, we'll take the mean of the predictions of all decision trees, and that will be our final prediction. Now, what are the assumption of random forest algorithm? Each tree in the random forest should be independent and not correlated with others. That is why we take randomly sampled data, we take randomly selected features, so to make our trees independent. The features used for training should contain useful information for making prediction. This comes now the assumption of random forest algorithm is at each decision tree in the random forest should be independent and not correlated with each other. The features used for training should contain useful information for making predictions. So here we should have domain knowledge of the problem also. Highly correlated features reduce the benefit of multiple decision trees, and more decision trees reduces overfitting and it improves generalization. Random forest performs best when there is enough data. So for random forest, we should have a large amount of data, and if we use more number of trees, it will reduce overfitting and it will improve generalization. Now let us see working of random forest algorithm. First step is bootstrapping, that is creating random data sets. The algorithm randomly selects subset of training data sets with replacement, and we call this process bootstrapping. Some data points may appear multiple times in one subset while others may not be included. So each subset is used to train an individual tree. Consider, for example, we're having 100 customer transactions. Random forest may select 600 transactions randomly, then it will train our tree. For example, it will train tree 1 on this 600 transactions. Then it will repeat the process. That means it will again select 600 transactions randomly and it will train tree 2. Again, it will select 600 transactions randomly, and it will continuously repeat this process. For example, we have to when we train our random forest, we have to mention how many decision trees we are using. Based on that, it will select that number of trees, and it will train those trees randomly. Now let us see step number 2. Step number 2 is random feature selection. Instead of using all the features, random forest will select a subset of features, and it will select these randomly at each split. This ensures that the different trees focus on different patterns, and it reduces correlation between them. Then step number 3. Step number 3 is growing multiple decision trees. Okay, first we have selected the data, then we have selected the features. Now we have to train our trees with these features and with this data. So each tree is trained independently on its bootstrap dataset and follow the decision tree learning process. Since trees see different data and features, they become diverse and independent. Making predictions. Step number 4 is making predictions. In this random forest, we can solve both classification as well as regression problem. So if it is a classification problem, then we will go for majority vote. And if it is a regression problem, then we will mean the predictions of the decision trees to make our final prediction. Final is the evaluation of model performance. Random forest generalize well due to reduced overfitting, and we calculate the performance using accuracy if it is a classification problem and mean square error if it is a regression problem. Let us see the implementation of random forest algorithm. For implementing random forest algorithm, we use scikit-learn library. In the scikit-learn library, we are having two classes. One is random forest classifier, another one is random forest regressor. Because random forest can handle two types of problem, classification as well as regression. In this example, we will use this iris dataset, which is used for classification. Here, it is already inbuilt in scikit-learn library. So we are loading this dataset and we are storing the features in X and we are storing the output in Y variable. Then we are splitting this in train data and test data. Here we are using test size is equal to 0.3. That it means 30% of the data will be used for testing and 70% of the data will be used for training. Then we are defining the model random forest. In this random forest classifier model, we are calling an estimator. Wait. Now we are defining the random forest algorithm. In this algorithm, we have to discuss how many decision trees our random forest will use. And this is the first parameter that we define in random forest classifier, and estimators is equal to 100. That means in this random forest algorithm, we'll be using 100 decision trees which are used for training as well as for prediction. After that, we are training our data using fit method. We are passing our x train and y train. After this, we are making prediction by calling rf.predict. It will predict the X test dataset. And finally, we are calculating the accuracy and we are printing it. Now let us discuss the advantages of random forest algorithm. Its high accuracy and robustness. It combines multiple decision trees, and by combining multiple decision trees, it reduces overfitting. Each tree makes an independent decision and the final result is based on majority vote for classification and averaging for regression. Second point is handling missing value and no need for data processing. It handles missing value by using mean or mode of the features split in different trees, and there is no need of feature scaling like normalization or standardization as we do in other machine learning algorithms like linear regression. We have to normalize the features, but here we don't have that need. So because it's making decision based on decision trees. It reduces overfitting compared to decision trees. Decision trees are prone to overfitting, but random forests reduces this by averaging multiple trees. It introduces randomness by bootstrapping data and selecting random subset of features, ensuring diversity in trees because we are selecting data randomly and we are selecting features randomly. That means it reduces overfitting. And random forests work well when we are having large data set because different trees are trained independently, and it makes us efficient for big data because in big data we are having multiple nodes, so we can train different trees on different nodes, and it can handle data sets with high dimensionality, that means with many features. Now let us see the key challenge of random forest algorithm. First, high computational cost and slower predictions. Because random forests train multiple decision trees, so there are hundreds or thousands of decision trees, which increases training time. Making predictions require aggregating output from all the trees, so it makes it slower compared to simpler model like logistic regression or decision trees. The second challenge that we face is large memory consumption because each tree stores multiple copy of dataset. It consumes significant memory. Bias towards majority class. If the dataset is imbalanced, bias towards majority class. If the dataset has imbalanced class, for example, rare disease prediction or fraud detection, random forest may be biased towards the majority class because it works by majority vote, meaning minority classes can prediction can get overlooked because we are randomly selecting the data. Maybe it will select only positive cases. For example, another challenge is bias towards majority class. If the dataset has imbalanced classes, that means we are predicting disease prediction or fraud detection. Random forest may be biased towards the majority class because it works by majority voting, meaning minority class prediction can get overlooked. Next is not suitable for real-time application because random forest is slow in making prediction due to multiple decision trees. For real-time application, for example, self-driving cars, low latency models are required. So we can't use our random forest algorithm there. If you have any queries, questions, kindly leave your query here. Thank you.